Alrighty, Chapter 6 review, Problem 1. The graph below shows the cost of gasoline changes over 1 month. According to the graph, the cost of gasoline blank decreases. Always, sometimes, never. Take a look at the graph. You can see it, I don't know, we'll just make believe that this is $2. Starts at $2, goes up a little bit, now it's like $2.30. Stays that way for a little bit, goes up a little bit more, now it's $3. Stays that way for a little bit, now it goes down. So stays, goes up, stays, go down, stays, goes up, stays that way. And guys, gas prices are super high now. So what we saw is that it goes up, goes down a few times, so it sometimes decreases. It ends on the high note. Thanks, Obama. All right, problem 2, we have a mapping diagram. You have -3, -1, 5, and 8 as your domain. So since -3, -1, 5, and 8 are your domain, you can get rid of that one, you can get rid of that one because those two have 6 in the domain, so these mean nothing. -6 is your only range. So these two pictures are good where everything goes here. Now, every member in the domain goes to the same thing. So this is like taking 4 darts and all of your 4 darts that you were throwing hit the same target, which is okay. So this is a function because x's don't repeat. So this says it's not a function, which only leaves us with B. Dunzo. All right, now we are asked to graph y equals -3x minus 3. The y-intercept is going to be the number floating around. When y is all by itself, the number floating around is the y-intercept. So -3 is the y-intercept, which means it could be you, it could be you, it can't be you, and it can't be you. Now, that's our y-intercept. Our slope is also -3, so it's going to have a negative slope. That goes up 1, left 3. B is not even a negative slope, so that kind of rules that out pretty quickly. B is out, D is out, C is out. A is the only one left. All right, problem 4. Find the slope of the line. All right, this line doesn't have any points, so I'm just going to throw a couple points on it. Negative slope, because it goes down and to the right, up and to the left, so that eliminates u, up 1 over 1, 2, -1 over 2, -1 over 2. There you have it. Problem 5. Y equals 8x plus 9. Well, basically what you're doing for this one, it says, oh, here's a y, find y for the given x. You're just taking this guy and substituting x for that guy. Just plug it in. So I'm going to write it over here. Y equals 8, and you're going to replace x with 9 over 2 plus 9. 8 divided by 2. Oh boy, am I having a hard time with that one. That was 36. Just kidding, 36. 36 plus 9 is 45. B. Okay, and here we are with this last one. With the last one we have, or last one on this page, use a graph or table to write a linear function that relates y to x. You could use linreg, but this is what I'm going to do here. I'm going to look for the pattern and use the fact that it's 0, 0, which means I'm not going to have a y-intercept. I'll use the pattern to figure it out. It looks like to go from -7 to 0, I add 7, and to go from 2 to 0, I subtract 2. So this is the same thing, add 7, minus 2, minus 2. Since slope is rise over run, we're going to view this as y over x. So my slope is going to be -2 over 7. Again, slope is rise over run, so y's over x, -2 over 7. So if my slope is -2 over 7, I need the one that's -2 over 7, which is that guy right there. All right. Problem 7, next page. We have another linreg type problem, so you can do linreg. In fact, all of these are linreg. Anytime you are asked to write a linear function, if they give you points, like the last problem, like this problem, like that problem, like that guy. You can do lin reg, but just in case you don't have lin reg or you don't want to do lin reg, we're going to look at the pattern again. So like we did last time, we're going to notice that this is going to go up 3, up 3, up 3. And this pattern looks like it's minus 7. Just kidding, up 7, up 7, up 7. I care about the y's over the x's, so my slope is y, 7, over x, 3. So I have a slope of 7 over 3, which eliminates a and eliminates b. My y-intercept is 0, negative 5. So my y-intercept is 0, negative 5, which means my y-intercept is negative 5. If y equals mx plus b, that looks just like lin reg anyway. My slope would be 7 over 3. My b would be negative 5. 7 over 3, x minus 5. D is my answer for 7. Okay, for 8 you could do lin reg if you wanted to, but let's basically do it the same way that we did problem, I think it was 3. Y-intercept is 4, so positive 4 for y-intercept eliminates D, eliminates A. Positive slope goes up, let's see, 1, 2. Look how it's weird. Look how it's weird. Up 1, 2, 3 over, 1, 2, 3, 4, 5. Up 3 over 5. Positive 3 over 5. So y equals 3 over 5x plus 4. If that threw you off, by the way, it's a positive slope, which eliminates b anyway, so you don't have to worry about too much. Again, you can do lin reg. And so you can do lin reg. I see that my pattern, my x is going up by 1. So up 1, my y is going up by 7. Up 7, that gives me a slope of 7, which eliminates u, and eliminates u, and leaves just one, baby. And that's b. But we've done enough problems just like that where I'm not going to spend too much time on it. Okay, page 6, really easy page. List the ordered pairs. So 7 maps to 5, so that makes it 7, 5. 9 maps to 6, 9, 6. 11 maps to 7, 11, 7. 13 maps to 8, 13, 8. Dunzo. Right there, boom, C. Okay? Here for this next problem, 7 maps to 20, so 7, 20 eliminates U. 11 maps to 20, so 11, 20 eliminates C. 11, 20. 15 maps to 25, nope. 15 to 25. 19 to 25, 19 to 25. D. All right, problem 12. Problem 2 was very similar to this, but this one's actually a little bit friendlier. Basically, you're looking to see which one is a function. If you have a mapping diagram, if you see your input or your domain split up and hit different targets, that makes it not a function. So this is bad. Whenever you see that, that's bad. Now, you're allowed to have that. That's okay, but you just can't, no, that's bad. So looking at this, B has one of those problems. 9 is used twice, so that's a no. Looking at C, 9 is used twice, so that's a no. And D, negative 3 goes to 4, 1 goes to 4, that's okay. 5 goes to 12, 9 goes to 8, 13 goes to 12, that's okay. And oh look, another lin reg problem. Let's do this one a different way. Let's use some common sense. If x is 1, right? 1 jumps to 4, jumps to 7, jumps to 10. Y jumps to 30, jumps 30. So, okay, let's just do it the normal way. We have x seems to go up every single time by 3. Y seems to go up every single time by 30. That gives me a slope of 30 over 3, 10, which takes care of that. And that makes sense because basically what B is saying is y equals 10x. So whatever x is multiplied by 10, that gives you y. 1 times 10 is 10. 4 times 10 is 40, blah, 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 blah. The numbers actually make sense. Dollars and cents. Alrighty, page 8. Page 8, we are starting out by what function does this graph represent? Y-intercept is 0. It looks like the slope has you go, if I put a dot here, the slope has you go up 1, 2 over 1, 2, 3, 4. I don't know why I just didn't use that point, but up 1, 2 over 1, 2, 3, 4. Slope is a half, up 1 over 2. Y-intercept is 0. If y equals mx plus b, I get y equals 1/2 x plus 0. Slope-intercept form. I could have done lin reg. Problem 15. Describe the relationship between the two quantities. I have distance from home, I have time, and I have miles. So if I'm viewing this as a road trip, right, what's going on right here is I haven't started. Now I'm moving away from home, 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 moving away. Stopped, and I've stayed stopped for a while. So I start out by driving away from home and I'm stopping. So let's see what we have here for the description. We have distance from home increases at a constant rate and then stays the same. That's kind of true. The distance from home increases over time at a decreasing rate. No. Distance from home stays the same. No. The distance from home is constant at first and then increases steadily as time passes. No. I hate the way that they wrote this out. Basically, you're driving away from home at a constant rate, and then you stop. So I hate the way that that's worded, but technically that's true. All right. One of these problems, no multiple choice anymore. So y equals x plus 3, x is 8, 8 plus 3, y is 11. Very, very, very challenging. All right, problem 2 on page 9. For all you lin reg truthers, you can do lin reg with these 2 points and plug it in, but I'm not going to do that. I have 2, 4, 6, and then 26, I don't know, 78. This guy right here is right in the middle, right directly in the middle. So this is what I'm going to do. I'm going to figure out what I have to do to get from 26 to 78. In order to get from 26 to 78, I'm going to do some backwards math. 78 minus 26 is 52. So in order to get from 26 to 78, I have to add 52. Now 4 is directly in between. So I have to see what directly in between this is going to be. So I'm going to take that 52 and cut it in half. Divide by 2. Gives me 26. I'm going to add 26 to 26. That's going to give me this missing term. 26 plus 26 is going to be 52. And then just to double check my work, if I added 26 to 52, I would get 78 here. Now, if you're like, I don't like that at all, then do lin reg on these 2 points, get yourself an equation, plug in 4, and then you're good. All right, short answers. Now we're getting into the nitty-gritty. Gloria makes and sells handmade greeting cards. Ooh, the scatter plot shows the number of cards she made over a 10-hour period. Find the equation of a trend line, and I did not teach this to you yet. Ignore 1. We'll worry about that. But if you're dying to know, do lin reg, pick these points, actually say what these points are, do lin reg, and you'll get an ugly equation. Sorry. Use the graph or table to write a linear function that relates y to x. All right, you could do lin reg. I won't, though. This is what my line would be if I were to actually connect the dots. Y equals mx plus b is what the equation always looks like. Like I said, you could do lin reg, but I won't. My slope has me, if I'm going from this point to this point, going up 1, 2 over 1. So my slope is positive 2 over 1, 2. My y-intercept is negative 3. Y equals 2x minus 3. Dunzo. All right, page 10, problem 3. Lin-reg. It's asking the same thing. You're just writing out an equation, Lin-reg. But instead of Lin-reg, I'm going to use common sense. All right. Y equals mx plus b. I'm changing -1 to -4. I'm changing 0 to 0. I'm changing 1 to 4. I'm changing 2 to 8. I basically just multiply all the x values by 4, and then I get my y value. So whatever x is times 4, and I get y. So whatever x is times 4, and I get y. Easy. Linear, nonlinear, explain. I won't do the explaining. That's linear. That's not. I don't think I need to explain myself. This one I might explain it a little bit. If you're given a chart, you're looking for patterns. My pattern here in every time is 0 to 3 is +3, 3 to 6 is +3, 6 to 9 is +3, 1 to 4 is also +3, 4 to 7 is +3, 7 to 10, is +3. +3s all around, +3s all around. This is linear because it follows a pattern. This could have been +8 +8 +8. It's not the fact that they're all 3. It's the fact that these are all the same and these are all the same. That's what makes it linear. Page 11, problem 7, I'm doing the same exact thing where I have to find out if that's linear or not. Follow patterns. To get from -1 to 3, I add 4. To get from 3 to 7, I add 4. To get from 7 to 11, I take Main Street. To get from 5 to -2, I subtract 7. To get from 2 to -16, I subtract, well, I don't subtract 7, I subtract 14. And to get from this to that, I subtract 7. So I jumped. My pattern changed. Since my pattern changed, this guy's going to be nonlinear because the pattern is not consistent. Okay. Graph the function. I don't have a picture. Shame on me for not graphing or making a picture for you. But if I'm going to draw a sloppy graph, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, put a dot at the +3. I could go up 1, 2, 3 over 1, 2, or down 1, 2, 3 over 1, 2, down 1, 2, 3 over 1, 2. Perfectly drawn line. Awesome. Now we're at the others. The table shows how much a carpenter charges for work. Is the relationship shown by the data linear? So again, looking for patterns. This one goes up by 1, up by 1, up by 1. This goes up by 15, up by 20, up by 20. 15 is not the same as 20 and 20. That's a nonlinear because the pattern changed. Baby.